Hello, this is our team, Menna Ashraf, Nouh, and Maya Tarek. In this video, we're going to discuss the problems we tackled, our approach to solve them, and finally, a simulation of the output.
Despite the slightly increasing attention to the needs of handicaps, they are often ignored in our society on a general scale. What might be an easy everyday task to another person could be a challenge for a person on a wheelchair. A well-formed society should integrate all sectors of people that contribute to it and attend to each sector's needs. From this point rises the motivation behind our project, which is to help what we believe is a sector in the society that is not properly attended to. This sector represents people with special needs, specifically handicaps. Our project aims to introduce models of real life solutions that could be implemented on a larger scale.
The first problem is when a person in a wheelchair tries to climb up or down a flight of stairs. We aim to solve this problem by signaling the stairs via a button to turn dynamically into a ramp. We constructed a flight of 3 stairs. Each stair is mounted on a pivot. We then attached a servo motor to each pivot. We connected the wires of the 3 motors along with the Arduino board and the button on a breadboard. When the user presses the button, the motor induces the pivots to move, which makes the stairs turn into a ramp for sufficient amount of time for the person to climb up or down the ramp. Then each of the 3 stairs return back to their normal position. Here's the simulation. The user presses the button, the stairs turn into a ramp. Assume that the Pepsi bottle is our handicapped person. It climbs down the stairs wait for some time, then they return back to their normal positions.
The second problem, which is divided into two sub-problems, is when an individual on a wheelchair tries to drink from a water cooler. The first sub-problem is getting the water to fill the cup without having the person reaching for the tap, since it could be difficult for him either too far or too high to reach. The second sub-problem is getting the water to stop.
While using the pump, we found that it needed power supply of 12 volts when we only had one of 5 volts. Therefore, we used an adapter that supplied us with the 12 volts and a transistor to connect the control signal coming from the Arduino board with the pump.
Here's the circuit that contains the connections that control the pump. We installed a force sensor that would sense the existence of a cup on it. When the user put the cup on the force sensor, the buzzer produces sounds and the pump starts filling the cup with the water. To stop the water flow, we resorted to using a button. Once the user presses the button, the water flow stops. And here's the simulation.